Hello everyone, welcome again to this demo. This is the fourth part of this tutorial where we're demonstrating the capabilities and functionality of the SV3 MIPUD5 generator. In this section I will demonstrate a few more things that we can do in our test setup here. So if we continue with the same setup, you might recall that we were sending a color bar pattern. And the default image format is a 24-bit image, but this can be changed over here. So there are a number of options. If we wanted to send a 30-bit pattern, we simply pick the RGB 10-10-10 option, and that will do that. And another feature I wanted to show was also the ability to split the data and change the number of lanes over which it is sent. So by default, we were sending it over 4 lanes, but this can be changed so that the data is sent over 3 lanes. So we will do that change, and we will hit run. And it should go through, took a few seconds. And now the settings on this side also have to be changed. So I've already changed it to 3 lanes over here. So we send the data on 3 lanes on the TX side, and on the RX side, we are seeing 3 lanes. The data rate is correct, and all that needs to be done is that we hit run. Everything else is already in place. And the test is done, completed. We can see the results in the results panel here, and I'll show that. So now that we've sent the data over 3 lanes, we can see here how the data is split. So the byte information we can see is split across 3 lanes here. And just to compare it with a previous example where we sent it over 4 lanes, so I think this was trying to find a 4-lane example. So here we have the data split on 4 lanes, and if we look at the DSI packets, you will see the byte information is split differently. So here we had it evenly split across the 4 lanes, but here we have an extra byte that goes onto the first lane. So this just validates the fact that the data was split on 3 different lanes this time. And again, we sent a color bar pattern. And here you can notice the data type that we changed. It's registering as a 30-bit image this time, where it was 24 bits before. So this also is confirmed over here. This is what we sent, and this is what we received. So this is a very nice functionality of the generator that's available for the user. Another functionality that is also very useful for the purposes of automation is that all this entire setup can be very easily outputted to a Python script if there was a need to run this directly from Python. And this can be done using the test as a Python script option. So this is a feature in the utility drop down. So if you go to utilities, it's test as a Python script, and this feature allows you to basically output a script named myscript.py, which has all these settings in it, and is very useful for automation purposes. And we simply once we hit save, the settings we had are saved onto the script, and we can see here that the test was saved in this particular directory. And if I go to my directory, which I had opened previously, there's a folder called test as a Python script, and you can simply go and open the script, and all the information that we had in the GUI is now transcribed in this Python script. You might recall that, for example, the image settings that we changed here, the data rate, and all the relevant parameter, the test procedures are all in the script, and this can be run directly from Python. So it's a very useful feature and very effective for automation. And all this can also be manually, the GUI itself can be used to manually write out the test procedure. And I will just demonstrate using a short example. So for example, we had earlier applied SKUs, data SKUs. So we can simply write it down uh, manually here. So as soon as we write MIPI generator, so that's the component that we're interested in, once we hit dot, drop down comes up, and all the options that are available to us appear here. So we wanted to, let's say, apply data SKUs. So we can manually just click this and very easily apply SKUs. So let's say we want to apply a SKU on the first lane of 70 picoseconds, no SKUs on the other lanes, and we do that. And then we just do an update to the generator and with this new change. We hit update. And let's say we also wanted to go back to a 20, let's say we wanted to enable the virtual channel, which was something that we did earlier. And right now it's disabled. So we can again simply just type in the component name, which is DSI video color bar pattern. And we hit virtual channel equals 1. And that's done very easily. And again, we just do a quick update to the as well. And if there was any other change we wanted to make, let's say we could also change the lanes again. So MIPI generator dot data lanes. So we want to send it our data on 4 lanes now. And we do an update. Easy enough. And everything is ready to go. So let's say this is the procedure we wanted to implement. We simply type it out in Python and we hit run and it goes. And the update is completed and it can be captured on the other side as we have done previously as well. So this is a very simple procedure, and I will end the test here and hope that this was hope you enjoyed this video. Thank you for listening.